Hey guys, welcome. So I know a lot of people have these little remotes and they're used for opening and closing the chicken coop door, as you can see here. And these remotes, I mean, you have to be pretty close by to use them. And if your chicken coop is a ways off from your house, for example, and you just don't want to get up and walk all the way there, this can be a problem sometimes. And also, you can't control it with your phone. So in this video, we're going to make this chicken coop door controllable with our phone and pretty much from anywhere. Okay, so here's what I have in mind. I will use an ESP32 development board like this one, because you can program it with pretty much anything, and it has a Wi-Fi radio. This specific one actually has an external antenna plug here, so we can insert any size antenna that we need if the Wi-Fi is like a distance away. And we can basically access it through the network. And I'll also be using these two devices. One is a transmitter, I believe, and one is a receiver. And these are 433 megahertz receiver and transmitter, because that's what the little remote uses. I just know that from somewhere, I forget where, but I just know that these remotes use that frequency. And the idea is to actually design a 433 megahertz transceiver, so we can basically have a little device that we can put on our network, and we can receive data from it and respond to it in some way, maybe some sort of sensors or whatnot, or triggers that we might want to respond to, and also use it to send data using that frequency to any number of devices. So this is not just for the chicken coop door, we will use it for other purposes as well. And I'll make it very simple. I'm going to be using one of these what are these boards called? Basically, these boards have a bunch of holes here. I guess they're called development boards, or I forget what they're called. And we'll just use one of them to... This one's too small. Let's see which one we... So this one would fit an ESP32, and possibly these little... Let me see if I can fit it in here. I want to make sure that it's spaced out correctly. This I will insert in here, and this one I will insert maybe somewhere right here. I think that's pretty good. I think that should work for us, so I don't need the rest of these boards. These are actually really nice when prototyping. I guess these are called proto boards, if I'm not mistaken. But yeah, I got these on eBay for maybe like 10 bucks, this little box of boards. And I also have these headers, which I'll use for the for I guess all three of these devices. So we just solder in the headers, but I didn't solder in all the pins of the ESP32 headers, and the reason why is because we don't really need to. I will probably just solder the pins that we'll use, and the pins that we'll use will probably be like, I don't know, might be like 4 or 5 pins. I know 1 or 2 of them are actually just for power, and then 2 data. So now we need to wire it up, and I actually have the schematic right here with me that I just made, and we have the ESP32 right here, and we have the voltage in and ground, and then we have the receiver module, and also the transmitter module. And both of these modules also have VCC and ground, which are connected to positive 5 volts. And I guess in our case, since we will probably be powering the ESP32 through the USB here, we will route the VCC and ground directly to the ESP32. So basically ground is right here, and we also have positive 5 volts right here, so we'll wire that up to that. And then each of these modules connects to D0 and D1. Those are the pins that I've chosen for this, but we'll see if we need to update any of them. So yeah, let's go ahead and start soldering all the connections. Okay, I think it's ready for testing, and the way that I'm going to test it is I will program it with the ESP home, and then basically read the data coming from the controller, the remote, to see what it is, and then we can program the ESP home program, basically flash this ESP32 by sending the same code that the controller sends, so that the chicken coop would actually respond to this transmitter. And the way that ESP32s are usually programmed through ESP home is by plugging it into the computer that is doing the programming, and basically through the USB. So let me go ahead and do that. I just wanted to mention that these little modules here, the receiver and the transmitter, I got these on Amazon for like, I don't know, I think I got like maybe 5 of them for $10 or so. They're still on Amazon. Okay, so yeah, let me go ahead and plug it into my computer, and we'll start programming it. But before we do that, I actually want to connect a little antenna to it. And this is for reception, but also sometimes these radios can burn out without an antenna, so I just want to make sure that we have something connected to the antenna port. I'll be using this antenna for this whole device once we finalize it. So we're going to click on Add New Device right over here, and it says device needs to be connected to a computer using a USB cable, which I have done. I'm going to click Continue, and then name this device as, say, 433 megahertz transceiver, something like that. Click Next. I'll select, in my case, ESP32, the base one, and I'll skip the installation for now. So it's offline because it hasn't been installed yet, but let's go ahead and click on Edit. And what we have here is some basic information that will be used to configure this ESP32 device. So basically it gives you an API key, and over-the-air password also. And it also configures it with the Wi-Fi credentials, the Wi-Fi credentials are actually stored in the secrets file somewhere on Home Assistant. And it also creates an access point to access it, so basically the fallback hotspot in case Wi-Fi connection fails. So this is the base ESP home configuration. So you'll configure it and you'll be able to view the logs, but it really has nothing else on there. So what we want to do now is actually add the 433 megahertz receiver module. And the reason why we only want the receiver right now, just for now, because we want to see what kind of codes are being sent by the remote. And I just pasted here the remote receiver. So remote receiver components lets you receive and decode various common remote control signals such as infrared or 433 megahertz radio frequency signals. So you can read more about it right here if you click on the link. It's on their esphome.io. And then we need to configure the pin. And the pin, it has to be a GPIO pin, and the mode is input since we're receiving it. And we're going to say inverted true for now, and some other configurations here to basically filter the signal so we don't get too much junk coming in, because sometimes the radio can be a little bit too sensitive to random noise. So basically all this stuff we're going to leave as is, and I'll include the entire configuration for this device in the link in the description so you can actually reference that. But let's go ahead and actually save this as is, and then let's click install to install it. And we have a couple of options to install this, and the first one here, the wirelessly one, we can do once we install the initial USB home image onto the device, but we haven't done that yet, so we can't do it. We can click on this, and it's basically going to prepare and build the image and then tell us to go to ESP Home web builder to install it. I'm actually going to, and this is the same thing I think, and I'm actually going to basically manually download or manually build and download the image, and then I'll go to ESP Home device builder and upload it that way. So let's click on manual download, and it's basically building this image inside of Home Assistant, and once it's done we will be able to download it. So I'm just going to let it sit here for a few minutes and build it. Now that it's finished, it says what version do you want to download, factory format or over-the-air format. We will click on the factory format and actually download it right here. I'm going to say keep. So now what we will do is we're going to close this and click on install again, and then we're going to click on plug it into this computer and click on Open ESP Home Web. Then we'll click on Connect, and now we can select the USB port that the ESP32 is connected to, which in my case is right over here. If it's not showing up here, make sure that the cable that you're using is compatible, because some of these cables might just be for power and data might not be supported. So make sure your cable's correct, and also make sure that you have the right drivers installed for the 2102. I guess in my case it's a 2102 ESP32 drivers for the Mac. But I'll click connect, and then I'll click on install, and I'll select the file that we downloaded that was just built by Home Assistant, and then click install. Alright, it has been installed. I'm going to click close here, and I'm actually going to go ahead and close ESP Home and go back to Home Assistant here, and it's shown as online. Sometimes it might take a couple seconds to actually get online, but let's click on logs, and we can actually click wirelessly now that Wi-Fi has been configured for the ESP32. Okay, it's telling us the basically the IP address and all the information, like the Wi-Fi access point that I connected to. That's what I have configured for it to connect to, and then it tells us the host name for this ESP32 device and the receiver information that we have configured. So I guess now what we want to do is use our little remote that we used for opening and closing the chicken coop door, and try to press the open or close buttons to see what codes we get. Alright, so look at that, guys. So we're pressing the open and close. As you can see, it's a little messy, but the reason why is because of all the noise, and I guess the signals kind of run into each other. But I believe this is the value that is being set for the close. And this is the open, maybe. Let me try the other button. No, okay, so sorry, I was wrong. So one is this and the other is this. So one is closed and the other is open. So we just have to take a note of this, because we'll need to know which one to send when we close and open the chicken coop door. So just copy and paste this somewhere. Then I'm going to click stop, and we'll modify this. I'll actually keep this receiver here for debugging for now, but I won't be using it for anything else for the moment. And then we'll paste the remote transmitter, which is also can be found on esphome.io. And we will specify the pin for the transmitter. And that is it for now. But the thing is, we're not done yet, because we actually need to configure like something to use this remote transmitter. And what we can do is we can actually create a device, or I guess an entity in Home Assistant called a cover, or basically like a door, that if you like, let's say, open a cover, it will actually send a signal to the remote transmitter with the open binary code. And if you close it, it'll send the close binary code to the remote transmitter. And I'm just going to paste it in here. But basically what this does is it defines a new cover. And we actually name it a chicken coop door cover. Device class is a door. And there's two actions. One is an open action. What happens when the cover is opened or clicked, or the triggered to open. And the other is a close action. And what it does is basically it does two things here. So the first one is this part right here. It first stops anything that's going on. So let's say the door is closing right now. It's going to press the stop action, send the stop action. I guess, it's not always the same for every single chicken coop door, but in my case, that's what I need to do. I need to stop what it's doing. And then it's going to send the open signal, and that's the value for open in my case. And the same thing happens when the close action is triggered. It basically first stops everything, and then it sends the close value, which is almost the same as this, but it is slightly different. There's a couple of bits that are switched here. But one other thing that I wanted to mention is the pulse length. Pulse length is 300 here. And the repeat, I actually set it to repeat 10 times. So basically, it doesn't just send one signal and that's it. It actually sends it 10 times. And the reason why is because the receivers on the chicken coop door, it doesn't always catch a single signal. Basically, there's a lot of noise as well, so you just want to send a lot of it and hope that at least one catches it. So in my case, 10 is enough, but in your case, 5 might be enough. Maybe you might need to do 20. So that is pretty much it for the configuration. We're going to save this and click install, and it will install the configuration for the transmitter on the ESP32 device, and it'll also configure the cover entity that we just configured in the YAML file. Okay, so now that we have this device added and installed, we actually need to add the device basically as this I guess ESP home device as a device on Home Assistant. The reason why is because we, if you remember, we defined some covers here, and we need them to show up in Home Assistant. So we can go to Settings, Devices and Services, and if you haven't already added it, you'll probably see it show up here, or actually under Devices. And we can add it there, but I think I already added it. So it's showing up here. I'm going to click on it just to verify. Yeah, so we actually have the chicken coop door entity here. As you can see here, the cover is defined as 433 megahertz transceiver chicken coop door. So I'm going to actually open this cover. I'm going to open it in another window. And in this window, we'll go to ESP Home and look at the logs for this transceiver. And what I want to do is press the close button on this new cover that we just created, just to see if it's actually sending out a signal. Yeah, so as we can see, it actually triggered the let's see, Chicken Coop Publishing stayed open, so it's open right now. Command was close, and actually sent out, as you can see, it sent out like 10 or so commands for that. Now what if we press open? Yeah, same thing, but this time the command is open, so it seems to be working, which is good. So what I want to do now is actually define a cover with a state, so that I could actually add it to my Home Assistant, like a overview screen dashboard, and trigger it from there. And we can do that by going to File Editor and editing the configuration YAML file. So in this configuration YAML file, under File Editor, I'm just going to paste something in here. So we're defining a cover with a platform of template, and we're just naming it Chicken Coop Door. Unique ID is Chicken Coop Door Cover. The friendly name is Chicken Coop Door, and that's basically what's going to show up on the dashboard. And we also have a position template, and as you can see here, this position template is expecting a Boolean value, basically true or false. And here we're saying is whether it's going to be open or closed, and to see if it's open, we basically check this binary sensor called Chicken Coop opening 2, and if the state of that entity is on, then it's open. And this sensor is actually a Zigbee sensor that I installed on the door. If you can remember, on the door when it was opening and closing in the beginning of the video, it had a little sensor on it, and that's basically what will be used to determine if the door is open or closed. And when this cover open action is triggered, we'll actually call the entity that we just defined in the transceiver configuration. And also same thing for the close. We're just going to call the close cover service with the entity that we just defined in the transceiver. So let's go ahead and save that and restart Home Assistant. Okay, so I'm looking at the shed, and that's actually where I defined this cover for the Chicken Coop door, and the reason why is because that's the closest area to the chicken coop. I have this shed, and that's where we're going to mount this ESP32 device. And we can see this Chicken Coop door entity located here. We can click on that. And right now it says it's closed, so let's try to open it. Yeah, and it appears to be still closed, and I think the reason why is because I have the ESP32 device with me right now, and it's just way too far for the signal to reach the Chicken Coop door. So let me move it a little bit closer and try it again. Alright, let's try it again. Okay, so now it says it's open. And this open and closed state is actually determined by the sensor. So we know that it's open because the sensor is independent from the actual cover. Okay, so let me finalize this device by putting it into an enclosure and mounting it somewhere nearby so that we can actually use it and create automations and things like that for the Chicken Coop door. One thing that I want to do is create an automation for it so that the door would close automatically based on some time period. I know some Chicken Coop doors actually have like a light sensor that it will close based on how light or dark it is outside. But I've tried that before, and my chickens don't always abide by the lights, so it might close a little bit before they could actually get in. So I can actually configure it to close at, like, let's say a little past dark, so that I'm 100% sure that they're inside the chicken coop. And I can also set up automations that would basically alert me if the chicken coop door was left open, and did not close for some reason, or the other way around where it didn't open in the morning, and it should have been. So that all can be done with Home Assistant, which is actually kind of nice. So I'm going to go ahead and mount the ESP32 device into an enclosure and mount the enclosure somewhere near the chicken coop. Okay, so just to finalize things, I did move some pins around to make all this work, and I have the transmitter connected to pin 19 and the receiver connected to pin 21. Okay, so now let's go ahead and mount this into some enclosure. Alright, let's see, I'm going to unscrew this antenna. Okay, I think it's ready. I'm going to go ahead and close this up. I'll mount this antenna. This antenna is just for the Wi-Fi. The 433 megahertz radio should be sufficient. And now it's time to mount it. So let's go ahead and mount it. I'm on my phone right now and I have the Home Assistant application open. I'm going to try to open the chicken coop door by toggling the cover. That'd be it for this video. I hope you liked and enjoyed watching it, and I hope you found it useful. Don't forget to like and subscribe, and I'll see you in the next video.